also known as protein synthesis. And this is actually, looks a little complicated to begin with, but it's actually the same thing over and over and over again. The players here are the RNA, which is called messenger RNA, ribosomes, okay, and then we have these purple things, and these are tRNAs, and attached to the tRNAs are amino acids, okay? So what happens is this. Now, the actual sequence of this, when I model it for you, is not exactly what you see in the videos, but it's close enough, okay? What happens is this, is that the RNA and the ribosomes meet up along with the first tRNA with the amino acids, okay? And that's how it begins, all right? Now, again, this is the messenger RNA. The green is the ribosomes. This is the tRNA, or transfer RNA, and the transfer RNA has an amino acid attached to it. Now, how did I know what to line up where? On my messenger RNA, there are a series of codons. And codons are three-letter words, all right, that specify amino acids. So if you look on page 45, I think it is, page 45, there we find the genetic code, okay? Now, if you look at the genetic code, what does AUG code for? Start codon, and what is the amino acid? Methionine, okay? Now, on the tRNA, there is an anticodon that matches up with the codon. So we have U going opposite A opposite U, and C opposite G, okay? All right, so then at what's called the, that's all happening at the P site on the ribosome. At the A site, we have a second codon, CAU. What does CAU code for? Histidine, okay? So there's a tRNA that has histidine attached to it, and it's going to come into the A site like this, okay? And the codon and anticodon will line up. So we have C opposite G, U opposite A, and A opposite U. Okay. Then the methionine will scoot over like this. This tRNA will go away, and the ribosomes shuffle underneath so that a new codon comes up at the A site. All right? Then the tRNA will come in. Again, UUA codes for leucine. So the tRNA with AAU and the anticodon will come in. These scoot over here like that. This scoots away. The ribosomes shuffle underneath, so that we have a new one, a new codon at the A site, and this new codon is GCU, and GCU, if you look in the genetic code, codes for alanine. So this tRNA with the appropriate anticodon will bring in alanine. These scoot over here like that. That scoots away. Ribosomes shuffle underneath. The next tRNA comes in, bringing in serine, because we have AGU in that, in the codon, and AGU codes for serine. These scoot over here like this. That scoots away. It shuffles underneath until we get to, at the A site, we get UAA. Now, what does UAA code for? Stop. Okay? So there is no tRNA for this, all right? And what this is a signal is to stop synthesis of protein, and everything kind of falls apart, and you're left with your chain of amino acids that makes up your protein. Okay? So I'll just go through this again. Okay, so it all kind of starts together. by having the messenger RNA come in, and AUG lines up with UAC, and that codes, UAG codes for methionine. Then at the A site, we have CAU codes for GUA, and that then will bring in histidine. Methionine scoots over here like that. This goes away. Ribosomes shuffle underneath. We have UUA, that codes for leucine. The appropriate tRNA will bring this in. That'll scoot across. That goes away. Ribosomes shuffle underneath. You see, once you get the pattern set up, it's essentially the same thing over and over again. Until we have UAA at the A site, and that's the stop codon, and that's the signal to have everything stop. All right, so if you're in the morning lab, stay here. If you're in the